This is my poster for the 2025 Vista Conference. Um, the title is Easy to Make Sports and Recreation Technology. It was a project under a rehabilitation engineering research center, funded by the National Institute of Disability, Independent Living, and Rehabilitation Research, in the U.S. The overall goal of the project was to design sports and recreation technology for people with disabilities, primarily mobility and manipulation disabilities, so that they could participate in sports and activities that they haven't been able to before. Um, some of the sports and recreation that have technology currently are usually either on the high end of expensive technology, like basketball and rugby wheelchairs, and hand cycles that can cost thousands of dollars, or there's some books and things out there of making some very cheap and easy technology that, using like paper plates and straws and things like that. And what we were trying to fill was the gap between something that would be cheap and inexpensive that people could make themselves, but also be durable enough that they could reuse it, over and over again, and not need to keep making replacement parts. So we primarily were using 3D printing and um, other easy to acquire like bolts, Velcro straps, things like that that people could easily acquire. So the method that we were using is first we were getting ideas for projects. Reaching out to local sports and recreation groups, talking to people that we knew of, and we also have a link on our website that people could submit ideas. So once an idea comes to us, we would evaluate it, see if it fits within the scope of the project, figure out the types of design work that would need to be done and who on our team would need to be involved. And then we'd set up a list of design requirements and specifications. After that, we'd start designing it. Usually, we did some CAD modeling or something and presented that back to the person that had the idea, or one of another person with a disability that might be an end user. We'd get some feedback, maybe redo the design. And then once we felt pretty confident, we would fabricate one, again, primarily with 3D printing. And then we would have the person or somebody test it out. And then usually we got a little bit more feedback. And then we would continue on with redesigning until they essentially were satisfied with the device and didn't really feel like any more iterations were needed. Um, Once that was done, we finalized the design. We developed or put all the fabrication and assembly instructions into a document. We put it up on our website, and then it's available for people to download the design. For the 3D printed parts, we have the STL files, which is what 3D printers use, so people could download the design or the file and then either print it themselves if they had access to a printer, um, work with a university or a nonprofit that might have a printer, or there are also on-demand 3D printing services that they could just upload the file to that company and then they would print it and send it to the people. Um, and so that was kind of the overall goal and how we were doing it. And so I'd just like to go through a few of the projects that we worked on. Starting up here at the top, this was a game piece mover. It was basically designed for wheelchair users who might have to sit further away from the table to be able to move their own game pieces on board games. We were actually developing a board game around the time that this project was kicking off. And so that's where this idea kind of came from, was that we were designing our own board game. Um, so it's basically just a handle with a stick that has a hook at the end, so somebody could either push a game piece or pull it by using the hook on the other side to them. It has a Velcro strap, so it's adjustable for different size hands. but it also has a solid part to the hand, so that it's not flimsy in the person's grasp. Next down here, we have two different style of pool cue or billiards cue attachments. Um, One is a little bit more versatile and easy to move. So it just has two um, ovular or parabola shaped pieces that are pinched together with a bolt and wing nuts. And so you could just loosen the wing nuts and then slide it up or down the pool stick. The other one has a little bit more rigid clamps to it that aren't as easy to adjust, but they grip a lot firmer. So it might be something better if you were only going to ever hold the device at a single spot, that you could use that to clamp on a little bit harder. Um, then down here we have some swimming paddles. This was designed for somebody who came to us and wanted to be able to use a swimming paddle to train in the pool. Essentially, it causes more resistance in the water, so it'll strengthen your shoulder muscles and your arm muscles as you're going through the water. There are a lot of swimming paddles available out on the market, but most of those you need a flat hand on the back of them. Basically, everyone that we found. But this person had a kind of a central spinal cord injury that his hands were affected, but he could still walk. And so he had a Tina Desis grip, which is kind of similar to mine, that your hand's kind of always in a little bit of a fist. So we wanted to make it so that he could have his hand in that position on the back of the swimming paddle. There's two different designs for that as well. One, since he was able to grip it, had enough strength in his arm to, or in his hand to grip it himself. He used these ones at the bottom that weren't attached to him, but we also made another design that could have a Velcro strap to strap around the person's wrist if they weren't able to really grab it themselves. Um, Another project was a gear shift holder. This actually came to us by somebody who wanted to be able to drive a standard or stick shift car, but he had a right arm amputation. So he wanted to be able to use something with his prosthetic arm that would be able to go down over the shifter knob that would kind of snap into place, but also be easily removed. So what we made here was a little bit of a cup that the gear shift knob would go into, but it had spring detents. So as you put the knob in it, they would kind of snap into place around the knob, but it was also somewhat easily to overcome the force to be able to lift it back up off the shifter knob. Another project here was a miniature golf club holder to attach the putter to somebody's arm. This came to us by a wheelchair user who loved to play miniature golf, and usually, before we met him, would just duct tape the putter to his arm so he could play miniature golf. So what we made was something a little bit solid that would kind of clamp to the putter, but also had Velcro straps that would be able to strap on to the person's arm and then be removed relatively easily and not have to worry about duct tape on the person's arm. This also has clamps that are wing nuts, so they could be somewhat easily taken on and off the putter as well. Um, it also allowed for some movement. So if you needed the putter at a slightly different angle, you could loosen it, adjust the putter, and then tighten it back in. Similar thing over here was a clamp for a bowling ball pusher. Again, bowling ball pushers exist, but you need to grasp the bowling ball pusher with your hand, and if somebody didn't have the hand strength or grip, they really wouldn't be able to use the bowling ball pusher. So this was a way to kind of strap your wrists to it so that if you had good biceps and good arm movement, but just couldn't grasp it with your fingers, it would still allow you to be able to use the bowling ball pusher. Um, Down here, one more project is a computer mouse, which was designed early on, actually a little bit before we got the grant. that it works for somebody with a prosthetic hand that uses a prosthetic hook. So a typical mouse for a computer, you might be familiar with, wouldn't work very well with somebody with a prosthetic hand or a prosthetic hook. Um, so this just changed the shell of the mouse. The interior worked the same. There's a left click and a right click, but it has a spot where the hook can sit down in it and then just rotate your wrist left or right to be able to hit the left button or the right button. Um, so all of these projects were done and are on our website. Um, the we're still looking for more projects right now. That we're about halfway through the 5-year grant. So a few more things have come through since this poster was presented or submitted. We've done some things with cornhole, with attaching a string to a beanbag, so that somebody could put their finger through the loop of the string and be able to throw the beanbag without having to grasp the beanbag. We've done some more work with adaptive curling to be able to make the end of the curling stick more rigid so that it didn't break as easily. And we're also working on a few things right now of a different style of bowling ramp, some ideas for another idea for billiards of doing a different style of bridge so that if somebody was using our billiard stick adaptations, that they would be able to hold the other end of the stick as well. Um, and yeah, so that's the idea. That's some of the projects. The website for accessing this is listed right here, powerofplay .ahs.illinois.edu/device repository. Um, and yeah, anyone, if you're watching this video and have any ideas that might be something that would fit into this grant and would be useful, feel free to submit your ideas on the design on the website. Thanks.